So continuing on with section 10.3 in the dot product, I want to talk about the angle between two vectors. And it's not necessarily obvious that two vectors always make an angle. Okay, remember that the position of a vector doesn't matter, just its magnitude and its direction. So we can always move vectors around so that they're tail to tail. Okay, so that's what I've done here. I've just drawn two kind of random vectors that I made up here. All right, and this is just one example, but hopefully it'll convince you that this works with all pairs of vectors. If you slide them around in R3 or R2, wherever you are, and have them meet up tail to tail, then they're going to make a little plane together. I'm going to turn on the plane that this one has. Okay. So any two vectors that you line up tail to tail, you're going to be able to find a plane that passes through both of those vectors, right? And then if we look at that plane as if it's like the XY plane, there's going to be this angle that's made between those two vectors. Technically, it's making two angles. It's making that little one, and then it's also making that big one on the other side. So we define the angle between two vectors to be the one that's between 0 and 180 degrees, or between 0 and pi. So now that we believe that this angle always exists for two vectors, we've got A and B drawn with the same initial point, so we've got them tail to tail. A unique angle theta is formed. Okay, so why do we care about that? And what does this have to do with the dot product? Okay. Furthermore, this is true. This seems a little bit odd, but the cosine of that angle made by those two vectors is equal to the dot product of those two vectors divided by the product of their magnitudes. All right, that kind of came out of left field. All right, so I got two kinds of students in this class. There's the kind that when I put a formula like this up on the board, they're like, great, whatever, let's just do some examples. And then I've got the ones who are like, where the heck did that come from? All right, so if you just want to do some examples, that's exactly what we're going to do in this video. If you want to know where that formula came from, I'm going to make an optional video where I show you where this formula came from. You don't have to watch it, but if you're dying of curiosity, then that's where your answers are. All right, so we've got our mystery formula down there in the right-hand corner, and we're going to use it to find the angle made by two vectors. And again, if I were to go over to GeoGebra and plot these two vectors so that they were tail to tail, then we could see what that angle is, and we're going to be able to calculate it with the formula. Okay, so our formula says that the cosine of that angle is equal to A dot B. So we're going to dot these two vectors on top. And then we're going to divide by the product of their magnitudes. All right, and that's going to be cosine theta, and we'll figure out how to find theta when we're done with that. All right, so that means that cosine theta, let's just do these calculations, dot product on top. So we're just multiplying component-wise. So multiply x components, add, multiply y components, 2 times -3, multiply z components, and add -1 times 2. All right, so we'll do that arithmetic in a minute. Both of those magnitudes are going to need a big square root sign down here. Remember, we just square each component and add together. So -2 squared plus 2 squared plus -1 squared. And then in the second one, 5 squared plus -3 squared plus 2 squared. All right. All right, so a lot of arithmetic there. Cosine theta equals, up top, I've got, let's see, I'll take some notes up here, -10. This gives me -6. This gives me -2. That's a lot of negative. So -18. And on bottom, let's see, I get the square root of, this one's going to be 4 plus 4 plus 1. Square root of 9, I like that. And then the second square root gives me 25 plus 9 plus 4. That's 34 plus 4 is 38. Okay, so let's see. Squeeze this in up here. This tells me that cosine theta is equal to -18 over 3 root 38. And hey, the 3 and the 18 can simplify, right? 18 divided by 3 is 6. So cosine theta equals to -6 over root 38. Okay. All right, so I'm gonna go to my calculator. That's not one of my unit circle numbers. That's 6 over root 38. So I'm gonna type 6 over root 38 into my calculator. -6 divided by the square root of 38 is -0.9733 and change. So cosine theta, I'm gonna keep all these numbers in my calculator, but I'll just do a few decimal places here. 0.9733. All right, and when you wanna solve for theta, think back to trigonometry. We are not going to divide both sides of that by cos. Remember, it's cosine of theta, not cosine times theta. So the way you solve this equation is with the inverse cosine function, and that'll be above your cosine button. You have to hit shift or something like that. So second or shift cosine inverse of -0.9733. And I get 166.7 degrees or so. I'm in degree mode. You might be in radian mode. I don't really care whether you tell me radians or degrees as long as you indicate degrees when it's degrees, right? So that's the angle that's formed by those two vectors. All right, let's try another one. So another pair of vectors in R3, and they are written in IJK notation. So again, if you want to, you can convert these to component form if you're more comfortable with it. Feel free to leave them in IJK notation if it's okay by you. All right, so let's see if we can write less things here. I'm going to skip straight ahead to the calculations. Okay, so the first thing we do is dot the two vectors on top. So I'm going to multiply component-wise, -1 times 2, plus multiply y components, 3 times -4, and then multiply z components, -2 times -7. All right, and then we're going to need those two big square roots. Okay, I'm going to skip ahead before I fill in those square roots, and you'll see why. I'm going to try to save us some grief. I know I don't do that very often. Let's see. Let's just calculate what we got on top here. I get -2, -12, and 14 that I'm adding together. That's actually equal to 0, right? So I get 0 over. So the reason that I did this before I did the square roots is because that's 0 over, who cares? I don't care what's in the denominator. If I've got 0 on top, 0 divided by some stuff is going to be 0, right? Okay, so we'll just say pretend that I did and I didn't, but it doesn't matter. Cosine theta is equal to 0, right? And I can actually do this one without my calculator, right? Cosine is equal to 0. That's the x coordinate on the unit circle. That's going to be 0 up at pi over 2 and 3 pi over 2. And again, we're looking for the one that's between 0 and 180 degrees. So we're going to say this is 90 degrees or pi over 2. All right. So if you do run across one where the dot product is equal to 0, then you can just skip straight ahead to saying that that is a 90-degree angle between them. Who cares what the magnitudes are? Okay, so that's it for the dot product today. We know how to calculate dot products, and we know how to use dot products to find the angle made between two vectors. See you in class.